So one of the first things that stood out to me about the Walter Neff book when it comes to calculations was the way he describes and utilizes this thing called an exchange tableau and its use to perform the exchange method and basically and of course now the idea behind the exchange method is something that is not too difficult to understand, and I'll explain that first, okay? And then we'll talk about the exchange method and the rules, and then what an exchange tableau is and this kind of thing. So let's do that. So for example, the way you can think of the exchange method, before we go into the exchange method, the content of what our goal is with the exchange method is we can start with a set of linear equations like this. And what I want to do is I want to replace the u here with x. Okay, I want to exchange the u with the x. So now I'm going to perform that doing a substitution the way we might do in high school. Okay. So I could take this first equation because I want to exchange the x with the u, and I would solve it for u, right? So I would say, okay, x equals 3u plus 4v. I would subtract the 4 to the other side, and then I would divide both sides by 3. So I would get x minus 4v equals 3u, and I would end up with, dividing both sides by 3, I would get u equals to 1/3 x minus 4v, and then of course distributing the 1/3 inside, I would get 1/3 x minus 4/3 v. Okay, and so let me just rewrite this neatly. Okay, so u is equal to 1/3 x minus 4/3 v. Okay. And now if you notice, I can replace u in both of these expressions with this expression. Okay. Strictly speaking, I can just replace the first equation with this one because I've switched out the u and the x. But now to do this, to replace this u with the x, I'm going to plug it into the second one. Okay, so I'm going to get y equals 2 times u, right? 2 times u minus 3v. But what is my u? It's this expression. So it's going to be 2 times 1/3 minus 4/3 v minus 3v, right? I'm going to distribute the 2 inside here. So that's going to be 2 times 1/3. That's 2/3. 1/3 x. I'm sorry. I should have written that in there. You see? So it's 2/3 x. 2 times negative 4/3 is minus 8/3 v. And then I bring down my minus 3v. Now, I need to find out what is negative 8/3 minus 3 so that I can combine these two into one term. So let's do this over here on the side. What is negative 8/3 minus 3? Well, the first thing we notice is that we can't do it directly because this one's a fraction, this one isn't. So I somehow need to make the second one into a fraction. How am I going to do that? Well, what I'm going to do is I'm going to set it over 1, right? So I'm going to have negative 8/3 minus 3/1, right? And then what I'm going to do there is I'm going to say, okay, I need to multiply the top and bottom of this second fraction so that I can get the denominators to be the same. And how am I going to do that? I'm going to multiply it by a fraction that equals 1, but in such a way that 1 times that denominator will give me 3, so that they'll have the same denominator. And of course, in this case, 1 times 3 is 3, right? So it'll be 3 here on the bottom, and consequently 3 on the top. So I can rewrite this as negative 8/3 minus 3 times 3 is 9. 1 times 3 is 3. Negative 8/3 minus 9/3 is negative 17/3. So I end up with 2/3x minus 17/3 v. Okay, and so I can right, and my y here. And look what has happened here. Okay? What has happened here is I have exchanged x and u in this system, and I end up, when I use this equation and this equation, I can write down this system as follows. U is equal to 1/3 x minus 4/3 v, and y is equal to 2/3 x minus 17/3 v. Okay? So now there are several things that I want to point out to you from this example. Okay? The first thing I want to point out to you from this example is that the coefficient of this x, okay, is the reciprocal of this term, of this coefficient here. This was the coefficient of the u in the equation which had the variable I wanted to exchange it. And so in language that we're about to introduce, this 3 was our pivot element. I want you to also notice that this value, this 4, to transform it here, it was this value divided by the pivot and then multiplied by -1. Okay? Okay? I also want you to notice that this gets replaced by this divided by that. And I also want you to notice that this one gets replaced with, let me see here, this value times this one added to this one. Okay? And we're gonna see that in a moment. Basically, where that comes from is, so let me show you where all that comes from here. First of all, why does the sign of this one change, and why is this one replaced by 1/3 and this one divided by 3? Well, it's because here when we solved it, when we subtracted the 4 to the other side to get the u by itself, it took on a negative sign. And when we divided the whole thing by 3, that caused the coefficient of the x, the one we were interchanging with the u, to be replaced with 1/3. And it caused the other terms to be divided by the so-called pivot, the 3, right? And you can see if this was a bigger equation, like with 3 terms or 4 terms, like let's say x equals 3u plus 4v plus 5w plus 6z, something like bigger like that, you would see that the same pattern would have persisted. In our case, in getting the u by itself, in this case, we would have had to subtract all those other terms to the other side, which would have changed all their signs. And we would have divided all of them by this so-called pivot, the 3. Okay? And so that allows us to easily see that. Okay, and you're going to see that in the rules of the exchange step that we're going to look at more abstractly later. Now, with respect to the second equation, why is it that this is this -4/3 times this 2, which is -8/3, plus this one, which of course in this case it's plus and negative, so it's the same thing as minus. -4/3 times 2, that's -8/3, minus 3 is the same thing as -9/3, which gives us -17/3, which is here. Okay, where does that come from? That comes from this part here. This 2, right, which is this expression here, is being multiplied by that coefficient there, which comes from our solving of the first equation for that variable. Okay. Okay. And of course the fact that this coefficient came from this coefficient divided by the so-called pivot element comes from the fact that the 1/3 that we got from solving in the first equation for the u, that 1/3 gets multiplied by the 2. And that would be the same for, if I had more equations here, that would be the same story. Like if I had a third equation, z equals to, let's say 4u plus 5v whatever, that one would also have had, when I made this system, it would have been 5/3 also. Okay? Anyway, I'm going to stop there. I know that might be kind of confusing, but once we look at the exchange method with some matrix examples, you'll see how I use that language more carefully, and you'll see that this technique is actually quite useful and quite succinct. Okay, but I wanted to show you this kind of like pattern starting to emerge from this numerical example, so we can have some idea of like its origin, and it'll help to clarify the meaning behind those like rules.